Hi, welcome back to Missing Chemistry. This is electron configuration of scandium, SC lesson. Right, scandium is the 21st element on the periodic table, so we need to write a 21 here for our atomic number. And its atomic mass unit is going to be 45. Now, scandium has 21 protons, since the atomic number is 21. And since it's electrically neutral, it would have to also have 21 electrons. What about our neutrons? Well, go AMU minus protons equals our number of neutrons, right? So that would be 45 minus 21 would give me 24 neutrons. Pretty snarly, huh? Let's put 24 there. But before we do our electron configuration, let's remember that the S subshell can only hold 2 electrons, P subshell can hold 6 electrons, D subshell can hold 10 electrons, and the F subshell can hold 14 electrons. We're going to use something called the off-ball principle or the diagonal rule. And we're going to start sliding down this slide here on these arrows until we run out of electrons. So let's get going. So we've got 1s2, that's good, 2s2, 2p6, 3s2, 3p6, and then 4s2. Then we're going to stop at 3d1. Hey, pretty darn snarly. Really easy. Now let's look at our orbital notation, which is Hund's rule. Okay, so remember that in Hund's rule, you have to put an up arrow in every suborbit before you can put down a down arrow in that suborbit. So let's go up, down, cool, up, down. 2px, 2py, 2pz. Awesome. Then down 5 and 6. Pretty cool, huh? 3s, up and then down. Then 3px, 3py, 3pz. Then down, down, down. Pretty easy, huh? 4s, up and then down. And 3d x squared minus y squared up. Pretty awesome, huh? Now, did you really need all these extra guys right here? And the answer is yes. These guys are necessary, absolutely. And they're necessary because, electrons can jump suborbits or orbits when they become excited. All right, now, what about the noble gas? Well, the nearest noble gas of scandium is argon. So we call that Ar. And let's go ahead and get the valence shell. Right here is our valence shell. And when we write that down, then we're going to write this numerically in order. 3d1, 4s2. Pretty snarly, huh? All right, now, let's look at a couple things here. Remember that the D block is going to be n minus 1. That's really, really important to remember. Okay, so although scandium looks like it's in the 4th period, it actually would be 4 minus 1 giving 3. So the n value is going to be 3. Okay, it's in the D block, so the L value, the angular momentum, is going to be 2. And since it's the first element in that particular period, it's going to be negative 2 for our magnetic value. And let's look at that last arrow. That last arrow right here is going up. So it's going to be 1/2 positive. Well, that's it. You guys be snarling, and we'll see you back here at Missing Chemistry.